Hey all, this is Derek, and this is going to be section 8.3, rational equations. And so in this section we move from expressions, things we're simplifying, adding, subtracting, multiplying, dividing, to equations. So these are going to be where we have an equal sign in the problem we're actually solving for x. So we're going from like simplifying to solve. And we have some pretty set steps for doing that with the rationals. Rationals are going to be these things where they have fractions in them. So that's what a rational equation will look like, a fraction and an equals. And to solve these, the first thing we're going to do is get rid of all the fractions. So we're going to multiply all the terms by the LCD, and that will clear the fractions. Now, actually, I'm going to do a little thing right here by what I mean by that. So that would be a rational equation. It's not a very interesting one. It's really just a half plus a third. But so to clear fractions, I can multiply both sides of something by an LCD. So in this case, my LCD is 6. So then multiply both sides by 6. Here I'd have 6 over 2, so that would reduce to 3. Here I'd have 6 over 3, so that would reduce to 2, that equals 6x. 3 and 2 would make 5 equals 6x. And cat fight happening. Divide both sides by 6 and x equals 5/6, which makes sense because 1/2 and 1/3 is 5/6. Didn't break that up. Thor, dude, stop. Okay, so what we did here was we multiplied all the terms by the LCD, 6 to clear the fractions. And then this one did turn out linear, so we just got our x to one side, numbers to the other. It could have also turned out quadratic, so in that case, we get everything equal to 0. So like we have x squared plus 5x plus 6 or something equals 0. And then we're able to factor and solve that. So then the last thing we have to be careful of with these is checking for division by 0. So say I had something with this term in it that I was solving. If I had a 1 over x plus 2, x couldn't be negative 2, because if I put that back in for x, I would get 1 over 0, and that'd be division by 0. So that's what we'll call a variable restriction, is whatever would make those denominators 0, we can't get that as a solution. And if we do, then that just means it's extraneous and we have to throw it out. Okay, so for this first one, we have x's and 8s, and that's it. So what I'm going to do is I'm going to multiply everything by 8x, because that's my LCD. All I can do is multiply them together. And so if you look here, think about this 8x. Actually, let me write this like this. That's better. So then think about this 8x just kind of sitting up in the numerator and it being a canceling problem. So then these x's cancel, and that's going to leave me 8, and then still parentheses, still times that x plus 5, because we want to make sure we get it distributed. Here, these 8s are going to cancel, and I'm going to get minus 3 times x. And here, the x's are canceling, so that side will equal 16. And there's going to be no x squared term, so this won't be linear. So we'll go 8 times x, getting 8x plus 40 minus 3x equals 16. Combine our like terms over here, so that'll give us a 5x plus 40 equals 16. Subtract the 40 over, so 5x equals negative 24, and then divide both sides by 5. So it looks like x equals negative 24/5. And in this particular problem, x could not equal 0, so no troubles with division by 0. Okay, so for this one, we just have the one fraction with a b down there, so we'll do everything multiplied by b. So out front, we're going to get b times b, and that'll be a b squared. Here we get 9b over b, so those b's are just going to cancel. So that'll be a plus 9, and it equals negative 10b. And then this does have a squared term, so it's quadratic, so that's where I want to get to 0. So I'm going to bring this over and get descending order. So plus b squared, and then there'll be a plus 10b when I add that over, and then plus 9 equals 0. And then from there, we can factor and solve. Again, if you get something here that is difficult to factor, you can always toss in the quadratic formula, and that gets you the same solutions. So b plus 1 b plus 9 multiplies to 9, adds to be 10. So I get b equals negative 1 and b equals negative 9. And in this case, the restriction was b couldn't equal 0 again, so we're all good there. So for number 3, we're taking the same approach. We're going to use the LCD to clear out the fractions. X squared minus 4, if I factor that out, right, it would be x plus 2, x minus 2, and that's exactly what these are. So I'm going to multiply both sides of this by x plus 2 and x minus 2. X plus and x minus. And again, just that's the factored form of that. So here, I always think of it as whatever is in the denominator isn't going to survive because that's canceling. So the minus 2's are canceling in this first round, and we'd have 3 times the x plus 2. And then next we're going to have a plus 2, and then the plus 2's would cancel if you picture these sitting right up here, and then the minus 2 would be left. And then here, all that cancels, so we would just have 3x. And then distribute, and it looks like it's going to be linear, so we'll have 3x plus 6, 2 times x minus 4 equals 3x. I could be sneaky and cancel those 3x's, or if you don't note that, then we can also just do 5x. 6 minus 4 would be plus 2 equals 3x. I can bring the 3x over now, and actually let me show that because there's a piece there that messes people up. So 5x minus 3x, great, that would be 2x plus 2, and then right there is where people get a little screwed up and they forget to write down the equals 0. So they just kind of have this floating 2x plus 2 and don't know what to do with it. And it's that this side is now 0, so we'll bring our 2 over, and then 2x equals negative 2, and then divide it. And x equals negative 1, which is cool because x could not be 2 or negative 2. Those are my 2 restrictions from the denominator, so that one is okay. Okay, so for this one, let's get this factored so we can see it a little bit better. So this is going to be x. There's a common 6 in there, so let's get that factored out. X minus 6 minus 8, that's like over 1. Equals 1 over x minus 6. So let's see if we do like that, and then we're going to go 6x minus 6. Here we're going to go 6x minus 6 and 6x minus 6. So I'm just going to multiply each of these terms by the LCD 6x minus 6. So right here, that's all of it, right? So the 6's would cancel, the x minus 6's would cancel. The only thing that survives is the x. With this one, I have minus 8 times 6. So for right now, I'm just going to write minus 48, and then I'll take care of that distribute on my next line so that I don't mess up my signs or something. And then here's our equals. That's going to cancel those x minus 6's out. 1 times 6 is 6. And then let's distribute that 48, which seems like it's not going well, but it's going to turn out okay. Negative 48 times negative 6 was 288 equals 6. Combining my like terms, I'm going to have negative 47x, subtract the 288 on both sides and get negative 282. And then when you divide over that negative 47, you get x equals 6, which seems great, except our restriction from the original problem up here is x cannot equal 6. So this is the kind that is a no solution, or for the computer, you would put D and E, since the only thing that we came up with is the one thing it can't be. Okay, number 5. Again, we'll clear our fractions. And if you factor this out right here, it's what multiplies to negative 72 and adds to be negative 1. So that would be x minus 9, x plus 8, which is exactly what this side is. So again, I'm just going to do x minus 9, x plus 8 right there, knowing that's what this is. Same over here. And that should be a minus. There we go. So for here, the plus 8s would cancel, so I'd have the x and the x minus 9 would survive. And then up next, I'd have this plus 3, and then the minus 9s would cancel, and then I'd have the x plus 8 left. And then here, those are gone, that's gone, which is all that. And so I just have that numerator left. And then right there, I can see it's about to be a squared, so that means I'm gonna end up wanting to get everything over to the side and factor. So this is gonna go x squared and then minus 9x plus 3x plus 24, excuse me, equals negative 6x plus 88. And those two together, that's gonna go x squared minus 6x plus 24 equals minus 6x plus 88. And then here, when you add that 6x over, it's gonna cancel. So anytime you have like the same term on both sides, you can just cancel that out, and that's because it's the same thing as doing, but you're just indicating that that's what you're gonna do. And then I'm gonna do this 88 at the same time. We'll subtract that over, and then we get this rather nice looking x squared minus 64. And now we got that equal to 0. And remember, that's what we want, is our squared, everything on one side equal to 0. That's a difference of squares, so I can factor and solve. X plus 8, x minus 8 equals 0. And then x equals negative 8 and x equals positive 8. Except if we go back here to our variable restrictions, x cannot equal negative 8, so this one is fake. It also couldn't have equaled positive 9, but we didn't get that one. So only actual solution on that is x equals 8. And so for one like this, it could have worked out that both solutions worked, one solution worked, or neither solution worked. And we don't know until we solve and just kind of see how it comes out. But always remember to check back against those denominators. Okay, this next example is basically the same thing. It's just given with a little bit different notation. So they're saying f of x is 1 over x minus 3, g of x is 1 over x plus 3, and this is a three-parter. And so for this first one, we're asked to find f of x plus g of x equals 5/8. So let's write that out. So we're going to have 1 over x minus 3 plus 1 over x plus 3 equals 5/8. And then we'll use the LCD again to clear the fractions. This time the LCD is 8, x plus 3, and x minus 3. It's pretty much everything we have there. And I'm going to write LCD on that side since I didn't leave myself enough room. And I'll just point to this side. So here we would be thinking of the x minus 3's canceling, so we would have these two left up top. And again, it's this side. I just didn't leave myself space. And then the plus 3's would cancel, so it would leave us an x and x minus 3. Or sorry, an 8 and an x minus 3. And then here the 8's cancel, so I'm left with 5, x plus 3, and x minus 3. So now I need to distribute and kind of get everything to one side, it looks like, because I think we're going to end up with an x squared term over here. So this will be 8x plus 24 plus 8x and then minus 24. So those will drop out, equals. And then here you want to wait to do the 5. Do the FOIL first. This is basically the reverse operation of how you would factor. If you factor, you do the GCF first and then factor. So now we're undoing the factor, and then we'll do the GCF. So just working backwards. If you FOIL that out, you'll get x squared minus 9. 8 and 8 will give us a 16x right there. And then we'll distribute, and that's going to give us a 5x squared minus 45. And then let's bring this over since that is squared. And we'll have 0 equals 5x squared minus 16x and minus 45. So this one, on this particular problem, A lot of the versions come up nice where this is like x squared and something something, it just factors all easy. And then the one that I drew came up absolutely terrible, so I'll show you how to do the terrible factoring and just remind you that you can regenerate them. So if you happen to get one that's looking like it's terrible, you can always regenerate it, try to get one that's easier. But so here this is. So here we got to go 5 times 45, and that's a big number, 90, 180, 225, I think. It's hard to see what multiplies to be 225 and is 16 apart, since we're going to have that negative. So I tend to think of it this way: 5 times 45, and then 5 times, and I try to break this up. So let's say 5 times 9, and then see if I can spot the numbers from something closer to the primes. And so if I'm looking for two numbers that are 16 apart, 25 right there, 5 times 5 would make 25, and 9, and those are 16 apart, and it's the same value as this 5 times 45. I just kind of regroup the numbers. So that can be a nice way to spot it. If all of that you're just like, yuck, you can also just shove this in the quadratic formula, right? If the numbers are hard and it's difficult to factor, quadratic formula will get you the solutions every time. So I'll finish up the factoring here. So 0 equals 5x squared. I think I will do this one by AC. So I'm going to go plus, oops, nope, I'm going to go minus, because that would be the negative because of the negative 16. So minus 25x plus 9x minus 45. So from those two I have a common 5x. So we'll do 5x, x minus 5. From these two I have a common 9. So x minus 5. And then this x minus 5 out front. And then 5x plus 9. So for this one we got x equals 5. This side we got x equals negative 9/5. You can also do this by magic method if you prefer that. That'd be 5x minus 25, 5x plus 9. And then, oops, 25, and then just divide out the 5 right there, x minus 5, 5x plus 9. I actually like magic better, but either one of those methods works just fine. Okay, so part B on that is f of x over g of x equals 3 in this case. So we're going to go f of x is 1 over x minus 3 over g of x is 1 over x plus 3. So we're getting one of those complex fractions, and then that equals 3. So what we're going to do in this case is we still just have something over something equals 3. So if I had a over b equaled 3, I'd just multiply both sides by b, right? And that would take care of that, and I'd clear the fraction. So I'm going to clear the fraction twice eventually, but first off, I'm just going to clear this big ugly fraction with a 1 over x plus 3, the same as I'm doing right there. And then right here. So now these drop out, and I have this 1 over x minus 3 equals 3 times 1 would be 3 x plus 3. So if we end up with a fraction equals a fraction, we can cross multiply. It's the exact same thing as multiplying by the LCD. If I did x plus 3, x minus 3, think about it, the plus 3's would cancel. I'd have the minus 3 on this side, and on this side the minuses would cancel. I'd have the x plus 3. So if you have something of the form a over b equals c over d, that's where you can go AD equals BC. So that's what I'm doing right here. So x times 1 would be, or x plus 3 times 1 would be x plus 3. And this side, let me show that distribute as a separate step. So I'll just write that out. We'll run the 3 through. And let's see, we'll get x's on one side. So let's subtract x and get 2x minus 9 equals 3. You rewrite that up here. And then we'll add that 9 over. So 12 equals 2x, and then divide the 2. So x equals 6. And that is okay because it couldn't equal 6 or negative, I'm sorry, it couldn't equal 3 or negative 3. So then for part C, for this one it's just saying f of x equals g of x, so that would just be 1 over x minus 3 equals 1 over x plus 3. And so we'll do our cross multiply trick again, and we'll just get x plus 3 equals x minus 3. And then what happens when we try to solve is it messes up and we get 3 equals negative 3. So that is a no solution, or DNE, for the computer. Okay, for these last couple problems, these are going to be literal equations, so we're asked to solve this equation for a particular variable. And in this case, it's going to be this a down here. It's pretty much the same math as what we've been doing. We're going to use the LCD to clear the fractions. So in this case, that would be ABC. Actually, I think I'll write it like that. So we're going to go ABC, ABC, ABC. And here the A's cancel, leaving me 5BC. Here's the B's canceling, so that's minus 3AC. And here the C's are canceled, so then I have 2AB. And then from there, I am trying to get A. So to solve for A, I want to get my A's on one side and everything without an A to the other side. So I think what I will do is I'll bring this one over, and that's also going to make the signs a little bit easier. So let's rewrite this as 2AB plus 3AC. And then if you notice, and this is the little tricky step, there's A's in both these terms, but they are not like terms, right? Because this says B, this says C, so I cannot combine them. But what I can do is I can factor an A out front. And what that does is helps me see what I need to divide out to get that A by itself. So once I write it like that, then hopefully it's a little bit easier to see. I just need to go 2B plus 3C on both sides. So divide that out, and then we have A by itself. And so then this is what A would equal. Okay, for this last one, we'll do the same thing where we, okay, for this last one, we have fraction equals a fraction. We'll go ahead and do the cross multiply thing again. And we are solving for E, and again, notice there are 2 of those in the problem, so we're gonna have to do the factor trick. So this is gonna be A and then times D plus E equals E times C. And let's distribute that A through so we can clear the parentheses. So that'll be AD plus AE equals EC on that side. We'll bring this over, and AD equals EC minus AE. And then both these have E's in there, so we'll factor that out front. AD equals E, and then C minus A, and then we can divide that over. So AD over C minus A equals E.